Hello and welcome to another Seatrade Cruise Talks. The cruise industry, like countless other industries, is seeking new ways to effectively eliminate viruses in the air and on surfaces. One company that is confident it can remove contaminants using HVAC systems is the sponsor of this curated conversation, VIKAND. Here to discuss defeating airborne viruses is the company's Senior Director, Stephen McAfee. Welcome, Stephen, and thank you very much for joining us. Who is VIKAND and what role does the company play in supporting safe and healthy cruising?
So VIKAND is a leading global maritime healthcare best practice partner and solutions provider. The company offers a wide range of services and different product solutions to help ensure optimal levels of care and comfort for seafarers aboard the vessels they're sailing on. Our clients and partners trust VIKAND's commitment to the mariners at sea with the experience and expertise to help them to achieve higher levels of care aboard.
When it comes to ensuring a safe and healthy ship, many solutions are available and more are appearing daily. Could you tell us why VIKAND believes its HVAC system holds the key to disinfecting the ship?
So the nice thing with the Hygensea solution is that it actually works in conjunction with the existing HVAC system. So basically your HVAC machinery is the lungs of the ship. It's providing fresh air, it's circulating that air throughout the vessel, keeps everybody cool and comfortable or warm in the wintertime. And it reaches every single corner of the ship where passengers and crew are, living and traveling and, just basically aboard. As long as they're indoors, you're within, the comfort zone of the HVAC system. But by combining that with the Hygensea sanitizing system, we're actually able to create a healthier ecosystem aboard. The Hygensea solution is absolutely one of the best possible technologies out there. We mimic the sun's UV frequencies, in the atmosphere to produce hydroxyls. And basically that works by interaction with water vapor. So actual water molecules in the air react with this UV exposure, form hydroxyls, which then flow through the environment, destroying pathogens, mold, odors, VOCs, basically anything that's bad in the air, and as well as on surfaces as it begins to cascade out through the entire ship environment. So it's a proactive technology. It actually works with the systems aboard to sanitize every single area. And then that kind of ties in with how we're able to do every surface, every square inch of the ship, as opposed to just wiping down a surface, right? If you send a sanitizing crew who are doing a fantastic job already, there's still limitations of what they can reach, right? If they're not going to be crawling around within the vents, they're not going to be reaching behind bedposts, they're not, accessing areas that we can access and treat on the molecular level. It really is a revolutionary, means of distributed disinfection and sanitizes the entire interior ship environment.
What is the difference, though, between active versus passive solutions, and how do they install in the HVAC?
A passive system would be something like a filter, right? So you're putting a filter into your HVAC system. You're kind of just waiting for something to get caught up in it. And then similarly, when you're talking about point of treatment solutions, UV or, surface sanitation, they're both somewhat passive. You're kind of relying on pathogens to come to you and hope it gets treated at that point in time. They don't address a virus or a bacteria that's, open in the space. What we're doing, as I say, is an active solution. By producing hydroxyls, which form other oxidants that flow into the actual protected area, we are able to target a, pathogen or mold. We're living in the world of COVID-19, right? Everybody's talking about it. So when you're looking at that from a means of treatment, surface disinfection is one way, but all the data is showing that it's an aerosolized virus and droplets floating in air that are causing infection. So if we're treating the air itself, then you're eliminating that risk profile. And when you talk about surface sanitization, if you're looking at a doorknob, for example, somebody may have wiped it down with a disinfectant wipe, but was that left in contact long enough? Was it properly sanitized? What about other surfaces like carpets that are very difficult to clean? Vacuuming only does so much. You could steam clean it, but that's very, labor intensive. And a lot of these areas get overlooked and can be a breeding ground for, bacteria, viruses, other, pathogens. The basic gist of it is an active system is distributing disinfecting agents throughout the space. And we're actually working in that respect as opposed to a passive capture way. If you're waiting for a virus or pathogen to get into your HVAC system and get trapped in a filter, you're not addressing it in the space where it is actually most likely to infect a person.
We recently published an article about photocatalytic oxidation devices. Now, is Hygensea in the same category?
So the Hygency solution is actually a bit more advanced than traditional PCO devices or photocatalytic oxidation devices. PCO requires a secondary reaction with a catalyst after you have that initial high intensity UV light-based reaction, and hence the name photocatalytic. You have the photo aspect of it, you have the catalyst, right? So you have those two pieces. Those devices are fantastic. They really do work quite well, but they do have limitations. The catalyst is actually that limitation. So once it becomes passivated or contaminated, you no longer get that secondary reaction, which is what actually generates hydroxyls. And then even at that point, it's in pretty small concentrations in comparison when you stack it up against our technology, which is a photolytic hydroxyl generator. So we're relying only on the reaction of water vapor with the UV spectrum that we produce itself. There is no secondary reaction, so we're able to produce in very, very high concentrations and volumes, and safely distribute them throughout the ship.
So with that in mind then, what makes Hygensea stand out from PCO and other technologies?
So like I mentioned, Hygensea is a photolytic oxidation device, which means that we're relying only on a combination of UV wavelengths to generate hydroxyls. And this lets the system produce a massive concentration of hydroxyls that result in cascading and sanitizing oxidation throughout the protected space. So if you incorporate this system, the Hygency solution, into a total ship solution, you're hitting the bullseye on a number of very real public health targets. So first and foremost, you're creating a safe environment using nature's own processes. We don't use chemicals at any point in time, so there's no consumable. It's totally safe for everybody aboard, and by the way, it's currently used by multiple hospitals around the world to address this pandemic, both within the hospital itself and within infected patients' rooms. So that kind of highlights the safety of the system. And we take care of all airborne issues. It's not just viruses, it's smoke traces, odors, like I say, mold is eliminated by it. And actually one of the primary means of how it works is it destroys VOCs. So hydroxyl formation triggers this entire series of cascading processes which sanitize anywhere the treated air can distribute. So if you go looking at a ship from a stale kind of semi-humid environment, which is perfect for propagating all kinds of problems, you're wiping them out entirely, leaving kind of a fresh and clean air. Actually, our clients who do have the system have repeatedly referred to it as mountain air, right? We flip the switch, oh, it smells like mountain air. That's one benefit, right? So you get the kind of fresh and clean aspect of things. But then from an operational standpoint, the system doesn't produce or introduce any kind of a pressure drop like you would with more obtrusive filters. So you're destroying all these pathogens without affecting any of the design parameters of the ship's HVAC system. we've actually run simulations with one of our business partners, and by utilizing our system in conjunction with increased air recirculation levels, you can increase those levels to the max allowed by class, which actually results in a direct fuel savings rather than putting in a more obtrusive filter, which can actually increase your energy bill. Apart from the fuel savings, there's other challenges associated with higher resistance filters that offset the benefits. So we can really safely deploy this and use it 24/7 without any risk of UV exposure to passengers and crew, without any kind of pressure drop in the system. And just quite simply, we can purify the air and surfaces, we can prevent illness aboard, improve the efficiency of the vessel, reduce the operating expenses of the ship, and create a better experience for everybody aboard.
Wow, well, it's certainly impressive. You know, I'm impressed by just how much it can do. And, you know, the fact is that being that it's utilised in hospitals, it speaks for itself. Has Hygensea been tested and endorsed?
Yes, absolutely. So practically speaking, within the cruise industry, we have it on board 24 cruise ships. We have it on multiple mega yachts. It's been used in varying industries outside of the cruise space. So, you know, agricultural, industrial, commercial. And actually, one of the devices is a Class 2 medical device approved for use in hospitals by the FDA. And thankfully, that very rigorous testing regimen that the FDA prescribed provided us with data that showcases the system's efficacy against all types of pathogens. So we can wipe out all of the bad stuff in the air with a 99% reduction in about 10 to 15 minutes. And then you completely eliminate everything, you know, in the air from a pathogen perspective within about an hour. But that first and largest step is the 99% reduction, that first log reduction. And basically what it means is you can actively protect everybody's aboard so long as the system is running. Let's just say that somebody sneezes in a restaurant, and left untreated, that sneeze will travel around to a few different tables, you know, and potentially infect other people around the initial person. With a hydroxyl saturated environment, you'll immediately get to work killing off whatever pathogens are in that sneeze as soon as it happens. And obviously no system's perfect. I can't stop somebody from sneezing on somebody else. Like if I sneeze now and we're, you know, well, were we in the same room, I can't stop that, but it would absolutely protect any person who would otherwise be exposed to those pathogens within a few minutes, thanks to the destruction of the aerosolized contaminants.
From a health perspective, I would feel much more confident going anywhere, knowing that this solution was in place in that vicinity. But are there any other benefits?
Oh, no, of course. So from a physiological standpoint, and this is all kind of experiential data, but crews have basically said that they sleep better. You experience better respiratory function. And basically you end up with a greater level of alertness from the benefits of those two factors combined. So, you know, you're kind of just improving the general mood and enjoyability of the environment. From a real perspective, you see, or owners would see, reduced sick time and, you know, subsequently potentially reduced insurance burden. You know, the list goes on and on. When you have healthier crew, when you have healthier people, you know, there's a lower cost associated with that, and that's very well documented. You know, we can pull that from just about anywhere.
I wonder if you could just 100% clarify that this can definitely be deployed in cruise ships.
No, absolutely, yes, and like I say, we have used it on a number of them, but it's a very simple integration. We have a couple of means of integrating the system, from, you know, single cabins all the way up to entire ships, or, you know, large public areas. You know, if you look at some of the promenades aboard some of the largest in the world, you know, the air treatment systems for those are moving a lot of air, which is kind of a perfect environment for us to treat. But what we do is we just siphon off a little air from the HVAC system, treat it with our devices, and then cascade that air back into the system, which can sanitize either the entire ship or a specific targeted area.
Okay, but aren't ships already being sufficiently cleaned given the focus on VSPs and the now increasing cleaning efforts?
The protocols that are used in cruise lines are some of the best in the world. They really do a fantastic job of providing sanitization of their cabins and the public areas, better than most other industries out there. But there are limitations to what is achievable by, honestly, a very labor-intensive means of sanitization. So when you're sending a crew out, they have to try and reach every little area. And when you talk about again, I'm going to fall back to COVID because it is an aerosolized virus, the deposition of those viral droplets are not necessarily going to be on areas that are being cleaned. As I said, you might clean a doorknob, you might clean a sink faucet, but when you're having to disinfect the carpets, when you're having to disinfect the drapes, and that it does nothing for the actual air itself. So you may be getting 90% there by doing these existing procedures, but to provide a total protection, a total shipboard immune system, if you will, you have to be able to treat the air. And those VSPs are really built around intestinal illnesses like norovirus. They're not designed specifically for respiratory airborne threats. So that's really where we step in and can take it to the next level and really protect everybody aboard.
But what about other options, Stephen? How does UV compare?
UV has been talked about a lot lately. Far UV and different wavelengths that are being used as a disinfection means. And UV does work in certain environments, but there are limitations. So let's kind of talk about one of those to begin with. In short-term exposure, UV isn't necessarily a bad thing, but you know as well as I do, if you spend a summer day outside without any sunscreen, you're going to get a sunburn, and that's as a result of UV light. It's a spectrum that carries a lot of energy, and so when you're considering the potency of UV, yes, it can kill pathogens, but there's a few special conditions you have to meet for it to work, and you do need to be careful around it. So too much UV exposure can cause skin irritation, but also eye irritation, even in relatively low levels of exposure. And worse than that, problems with prolonged exposure, the health implications are very well documented in medical science journals. And then another problem is that UV actually destroys synthetic materials. So if you were to shine UV light on plastics or rubber or any other synthetic material, it's going to degrade them fairly quickly. So using it in public areas, you're going to actually see an impact on the materials used within the ship. And then the other issue is exposure time. So while UV may work well in a open environment where it's constantly shining, you don't get that same effect if you're putting UV into a high airflow environment like an HVAC system, because you do have to have a certain prescribed amount of dwell time for that UV light to actually have its impact on any pathogen that's flowing by it. And generally speaking, the airflows within an HVAC system are far too high in order to get that impact. This is a personal thought here, but I wouldn't necessarily recommend UV conventional UV in a HVAC system or in public areas. There's just too many risks associated with it for some minor improvements of the situation.
That's really good to know, really useful. Another technology though, based on ozone, how does that compare?
So ozone has actually come up repeatedly in conversations because it's a known disinfecting technology and it has been around for decades. Unfortunately, ozone can be pretty dangerous. It's one of the air quality parameters that's measured by the EPA when they issue warnings. If you live in a major city and air quality is being monitored, you may actually see reports on the morning news that, the air quality is bad, and most of that has to do with ozone. So it's ozone, particulate, CO2 levels. There's a few different parameters. But ozone itself in air, it is a corrosive particle. And even at low concentrations, it can have a detrimental impact on individuals who suffer from respiratory issues, like asthma or, and really any other pulmonary challenge. And the other thing with ozone is it's actually a fairly persistent oxidant. To put that into perspective, hydroxyl is 1,000,000 times more reactive to ozone. So if you put the two side by side, and let's just call them, rockets on a launch pad, the hydroxyl will have taken off, flown to the moon, and come back before ozone has even lit its engines. So, hydroxyls just provides such a greater level of sanitization without the inherent risks of ozone. And so, while ozone works great in water treatment, it's just a bit too dangerous for use in protecting passengers and crew. And actually, there are no ozone generating devices that are approved for use in occupied spaces, which is something that really kind of differentiates our system from kind of conventional ozone.
I just wanted to continue this theme of contrasting different technologies and methods for a little bit longer.
No problem.
To ask you, how do HEPA filters compare?
So you do have some limitations there as well. First of all, there's no ship that I know of which has a existing HVAC system that was designed to use HEPA filtration. If you take a conventional filter, take it out and put a HEPA in, you get a much larger pressure drop, which puts a lot more burden on the system. If it has the capacity to actually work with that filter, it's going to work a lot harder to get the air moving as it needs to. And then traditional HEPA, there's varying grades. Once you get into medical, it can be very effective at filtering, but again, that pressure drop is so massive it could never be integrated with a large existing HVAC system. So when you look at conventional HEPA, the filtration level is about 300 nanometer, which captures droplets pretty easily. But when a viral saturated droplet evaporates, as it would in a high airflow environment, again, speaking with coronavirus, that virus is only 125 nanometers in diameter, give or take. And so once that droplet evaporates and you've freed the virus and aerosolized it, it can actually dislodge from the filter media and just, keep moving. So, and that's to say that even these droplets are making it into the HVAC system in the first place. I'm not a virologist or an epidemiologist, but based on all the data we've seen, I think everyone's in agreement that, if you're hoping that you're capturing a virus with a filter, it's just too passive of an arrangement. It's like you really do need to have a system that attacks the virus where it spreads, and that's in the room with an infected individual.
And when it comes to, those people who may be watching and are interested in this, what is the typical decision-making process?
We've had a lot of interest since we've entered this world of COVID-19, and it really depends on the operator. Some of whom are ready to dive right in. We've had a few operators come to us, and we're already working on. We've just completed a full ship installation over in Europe. It looks like we're going to do another one here in North America, so that'll be coming out in the next few weeks. And then, there's others who want a lot of scientific validation, which thankfully we can provide. We have all of the empirical data to support our claims. It's one of the things that helps us differentiate from a lot of other systems out there. And again, that's thanks to the process that was followed for FDA approval of the MDURX model. So we can work with validation scientifically. We can work with short-term trial periods aboard to validate the results on the ship. And really, we'll work with anybody on this regard, whatever they need to move forward and feel confident that our system is working. We'll certainly support however we can. But as you can probably imagine, it's a fairly hot topic at the moment. So we're kind of in a first come, first served basis at this point in time.
I can imagine. Now, here's the billion dollar question. How much of an investment is this? And how do owners assess the return on investment?
Right. So that's a pretty broad ranging question. So it really depends upon the application. Looking at a small room, it's a minor investment. If you're going to full ship, it is a much larger investment. But what we've shown through our solutions ROI benefits with reducing load on the HVAC system and subsequently reducing fuel consumption. Using kind of a mid-sized cruise ship as an example, we've run simulations that show anywhere from a 3 to 5% savings in fuel in a year's time, which can offset the purchase cost of the system within a year. And so what you're doing is, again, you're reducing that load on the HVAC system. You're reducing the not only the energy used to run your HVAC compressors, but also reducing the cycling of those HVAC compressors. So there's a number of different parameters that we've looked at, and the tangible cost savings are substantial. So yeah, that exact model, and based on some assumptions on the cost of heavy fuel oil, we've seen ROI within 6 to 10 months.
Marvelous that you have the science that can back up everything around what you're talking about with me today. But can you think of any other benefits to this?
Honestly, there's a whole list of them. Nobody's operating now because of this disease, and so if we're able to treat that actively, we can help mitigate the spread of any virus aboard. So you're lowering liability, you're improving, I would say, comfort for passengers, and providing a sense of safety for them to come back to cruising. We can provide the highest level of sanitation in the air within 15 minutes. So, within a few minutes of turning the system on, if you're talking full ship, you've basically cleaned, everything in the air in those 15 minutes. And, that's a huge benefit. We do kill 99.9999% of bacteria, viruses, molds, mold species, and again, odors and fumes in the air and on surfaces. It is a natural process, so we're just using a proprietary system to, duplicate what happens outdoors on a sunny day, and that really helps to amplify nature's processes, right? So if you're looking at what happens outside on a sunny day, that only happens when the sun's shining. At night, those processes stop, but we keep running. So we're really kind of enhancing the environment around the clock.
Would you mind telling me, Stephen, on that topic, what does a typical installation process actually look like?
We generally start with reviewing the ship's drawings and reviewing the HVAC system configuration. And then from there, we'll run a survey aboard if it's possible to do so. And then when we get into the point of doing installation, we'll send a team to the ship along with all the material. It's very minimally invasive. Generally speaking, we are working in the fan rooms of the ship, so there's not a whole lot of disruption to operations aboard. Point in fact, nearly every system that we've put out there has been put in during operation. Small team of guys go out, they do their job, and they come off the ship. When we're looking at a small vessel, we would probably run with an induct solution, which basically just mounts into the ductwork itself. Whereas on a larger vessel, without naming names, we all know who's got the biggest. What we do there is actually work in the fan room and have a parallel circuit with the HVAC system. And like I say, you just kind of pipe off a little bit of air, treat it, put it back in, and send that cascade of sanitizing oxidants throughout the space. And we can do that for really any space aboard, whether it's cabins or the ship's hospital or spas, and all the way up to restaurants and promenades and the entire ship. It scales very well for really any application.
That's great that there's that flexibility. I know that I can't keep you, Stephen. I've got so many questions that I'd love to continue asking you on this, but where else can we expect to see Hygensea solutions moving forward? So
we have been in conversation with a number of port agencies around the world so that we'd be able to treat the pre and post boarding environment or disembarking environment. And, we really are looking to do that, throughout the terminal, when you're going through security, on the gangways, when you're making your way to the ship, and then the ship itself. So, ideally, you're really getting this protection from, the very beginning of a cruiser's initial entry into the cruising world, right? So the second you enter the port building, you would hopefully see these systems, protecting them in that environment. So, it's the potential for really providing a greater degree of protection and sanitation isn't limited only to the ship. We're really trying to work with port agencies around the world and class societies to make this a broader solution to provide a greater degree of safety for not only passengers but the crew moving on and off the ship.
What has really struck me about this conversation is that there is a clear return on investment. Reduced fuel consumption is excellent news for everyone, so it's great that your solution has the ability to do this while keeping ships virus-free. It's been a pleasure speaking with you, Stephen.
For anybody watching, we're happy to support and, look forward to seeing more people adopt this technology, because we do know that it has such a profound impact on, the safety and health of the ship and the overall indoor environment.
Thank you to VIKAND for sponsoring this curated conversation, and to you, Stephen, for joining us. We'll be back with another Seatrade Cruise Talks very soon, so keep an eye on our website at www.seatrade-cruise.com to see what's coming up, or follow us on social media. Thanks for watching.